Hi, everyone. Good morning, good afternoon, good evening, wherever you are joining us from. Welcome to another session of the AI paper writing clubs. My name is Victor Jacob Asukwo, and we are going to have a session today. Once again, welcome back to our session. Welcome back to Machine Learning Rio. Machine learning is an open source community where we teach, where we advocate machine productive machine learning, artificial intelligence, and everything that's just about artificial intelligence. So this community started for about a year now, and we have been having sessions. You can check out our social media handles on YouTube. You can check us out on LinkedIn and Twitter as well, which is now X. So our speaker for today is here already, and I'm going to add him to stage. And briefly, what are we going to look at today? Um, last in our last session, we talked about building recommender systems with LLMs and AI agents, whereby we dive into a deep learning research paper, and that is exactly what we are going to do. So we had the part one of the session then, and we are also going to have the part two of the session. So, to give you a brief overview of what we are going to do today, we are going to explore how we can leverage AI agents while building agentic frameworks. We are going to look at utilizing. Of course, we have a research paper here, which I'm going to share in the comments section, and do well to tell us where you are joining us from. Do well to share your name, the country, and where you are joining us from. So, and thank you all for joining this session. I'm going to I'm going to I'm going to give you a rundown of what we are going to do today. So first, we are going to look at how we are going to look at. Okay, let me just read what I have here. We are going to look at recommender AI agents, integrating large language models for interactive recommendations. And so traditional recommender agents, are great in leveraging user behavior and preferences to suggest relevant items. Example, Netflix movies, Amazon products, but they lack versatility in communication and contextual understanding. Meanwhile, large language models like GPT can reason, can explain, and can also do what? Can also converse, but they lack access to domain-specific data like product catalogs or user items interaction. This paper proposes interactive agents, a hybrid framework that combines LLM as a brain and RX model as tools. So in our last session, we discovered and we also discussed some tools like when we are looking at tools, we include that we included tools like SQL Sage and SQL Query. So in this session today is really going to be great. So I'll just pause for a while and tell you share this video, invite your friends, and we are going for a 30-second break. And when we are back from the 30 seconds break, we are going to jump right in. All right, so that's we had to add that little, break. So bringing up our speaker for today, Oluwaleye Kayode is a machine learning engineer. He serves as a marketing and communications lead at Hidden Developer Groups on campus, University of Ibadan, where he promotes developer events and fosters community engagement. Additionally, he is the co-founder um, of Buy Weekend Ibadan, supporting Python enthusiasts in their learning journey. He's passionate about AI, machine learning, deep learning, and a whole lot of everything related to AI. So at this point, we have Kayode on the call. Hi, Kayode. Nice to have you here. Yeah, so can't hear you. I think you can unmute your mic. Okay. Your mic is muted.
Oh,
Okay, so
sorry about that. Hi
no
everyone. Hi
problem.
Victor. It's really great to be here.
Nice to have you here today. So talking about your experience and being able to lead this machine learning good developer groups on campus as well. Can you tell us a little bit about your career, your journey, and your experience?
Okay, so a little about me. It's so I am an engineering student here in at the University of Ibadan, and I think I started to delve into programming. I think about a year or two ago, and then I started learning Python basically
Okay.
because it was a language that was simple to use, and it was not as complex as Java, because I initially started learning Java before, and then I found out that it was easy, and then I started to ask, oh, what can I use Python to do? And then I realized that, oh, there is something called machine learning that you could do. And then I started to try my hands on it, and that's been pretty much it. I found out that I liked machine learning, and I've always been curious basically as to how most of the products that we use, such as the search engine and the movie recommendation system on Netflix works, and quite a number of algorithms as well. And I realized that machine learning basically was the brain behind, more like the brain and the tool behind it, basically. And since then, I've just stayed curious and been learning, basically. And community has been a very
Okay. So that
important
is
role in my
really
journey. Okay. So, and then
okay. So
I,
that
I yeah, that's all. Thank you.
uh, that is really impressive. So without wasting any much for that time, we are going to proceed from where we stopped. So I'm going to share my paper and not my paper actually. I'm going to share the paper. So we continue from where we stopped. and I'm going to have a brief recap of what we discussed in our last call. Okay, so um, and just few seconds, we are going to have the paper. I'll also drop the link to the paper in the comment section so you can join us in the paper. Okay, great. So I believe we should be able to see my screen now. Okay, cool. Yes, so on the first day we talked about getting started with building recommender AI agent that's it's creating large language model for interactive recommendations and the justice to understanding the abstract, the reason beneath this paper, the introduction, and also went deeper to understanding how we can apply this paper or not just how we can integrate computer vision into AI agents to be able to serve us this purpose of making our computers have vision. And we also look at conversational recommenders and the different ways we can enhance them, why we need them. And we also look at the methodologies, information query, memory mechanism, as well as the system of tools. And lastly, we talked about the entire flow of the system. Talked about the entire flow of the application, starting from the viral pipeline of interactive agents, memory module consisting of candidate memory box, a long term and short term user profile, that's C, tool modeling consisting of various tools, a plan first execution strategy, and fine tuning of reclaimer. Planning module, that's the next, involving dynamic execution and reflection strategy, as well as open source of fine tuning data for reclaimer. So I think that really covered um, a lot for building introduction to this research paper. And today we are going to continue from there. So we are going to continue from plan first execution with dynamic demonstration. So Mr. Goyade, so would you like to continue and walk us through this part of the paper?
All right. Uh,
Okay, that would be great.
this is the
Okay, so I'll help you to do the
to scroll.
I'll
Okay.
still be using my screen. Yeah, yeah, yeah.
Okay. Cool. So you already went through the user profile. Okay, from the user profile.
User profile.
Okay, from where you stop. Where you stopped now. Okay.
Okay, you are starting from here.
Okay. Plan. All right. So I'll read it first before I then talk about it. So
Okay,
this is the section plan first execution with dynamic demonstrations. Rather than using the step by step approach, we are adopting a two-phase method. In the first phase, we prompt the LLM to generate a complete tool execution plan based on the user intention derived from the dialogue. In the second phase, the LLM strictly adheres to the plan, calling the tools in sequence while allowing them to communicate via the candidate bus concretely. The plan first execution consists of the following of the two phases. Plan. Here, the LLM accepts the user's current input X, dialog context C, descriptions of various tools F, and demonstration D for in-context learning. LLM formulates a Vidin. LLM formulates a let's scroll back up. Formulates a tool usage plan based on the user's intent and preferences, providing input for each tool, that is P to the power of T, which is equals to the bracket open curly braces P1 raised to the power of T to P raised to the power of T superscript T subscript N close curly braces. So then let me talk about the execution as well. So that's for the first plan. The second plan is the execution. The tool executor invokes the tool step by step according to the plan P and obtains output from each tool. That is O superscript T, which is equal to open curly braces letter O superscript T subscript 1 dot 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 to O superscript T subscript N close curly braces, which is equal to execution of open bracket P2. So basically, the output feedback of each tool FK is defined as OK, where the only item formation O superscript C raised subscript N from the last tool output serves as the LLM's observation for generating the response Y superscript C. The remaining information is tracked by the candidate memory bus for further reflection. And here we are summarizing the differences between our plan, first execution strategy, and step-by-step strategy, which executes reasoning and action execution alternately. While our plan while our plan first execution is a two-phase strategy where a series of execution is conducted followed by one-time planning. In step-by-step strategy, the LLMs are responsible for thinking and reasoning at each step. The task entails reasoning for individual observation, resulting in crafting demonstration comprising dynamic observation. Differently, the primary task of LLM in our plan first execution is to make a tool into utilizing plan, which could be easily guided by query.plan pairs. The foremost advantage of our plan-first execution resides in the reduction of API calls when employing n steps to address a task. Our strategy necessitates merely two API calls as opposed to n plus 1 calls in React. This leads to decrease in latency, which is of particular importance in conversational settings. Scroll up, please. And then the table talks about that. Let me scroll. I think you can scroll up to the table part. Okay, table property later. And then we see the table that is here. Property comparison. So this is basically showing the comparison between the React and the plan first execution. And this is the difference. We can see the difference in the basic idea in the ICL You can see the difference as well in the reflection and in the API calls.
So I think that's a very cool approach to building systems like this. Maybe you might want to talk about the reflections.
Okay. So, uh, despite LLM's strong intelligence, it still exhibits occasional errors in reasoning and tool utilization. For example, it may violate instructions in the prompt by selecting a non existing tool, omit or overuse some tools, or fail to prepare tool inputs in the proper format, resulting in errors in tool execution. To reduce the occurrence of such errors, some studies have employed self-reflection mechanisms to enable LLMs to have some error-correcting capabilities during decision-making. In the InteRecAgent, we utilize an actor-critic reflection mechanism to enhance the agent's robustness and the error-correcting ability. In the following part, we will formalize this self-reflection mechanism. Assume that in the teeth round, the dialog context is C superscript C minus 1 and the current user input is X superscript C. The actor is an LLM equipped with tools and inspired by the dynamic demonstration augmented plan first execution mechanism. For the user input, the actor would make a plan P superscript C, obtain the tool's output O superscript T, and generate the response Y superscript T. This critiques evaluates the behavioral decisions of the actor. The executional steps of the reflection mechanisms are listed as follows. Step 1. The critic evaluates the actor's output P superscript T, O superscript T, and Y superscript T under the current dialog context and obtains the judgment gamma, which is equal to reflect open bracket X superscript T capital C superscript T minus 1 PT or P superscript T rather O superscript T and Y superscript T close bracket. Then it's step 2. When the judgment gamma is positive, it indicates that the actor's execution and response are reasonable, and the response Y superscript T is directly provided to the user, ending the reflection phase. When the judgment gamma when the judgment gamma is negative, it indicates that the actor's execution or response is unreasonable. The feedback gamma is used as a signal to instruct the please scroll up. I think you scrolled past it already. Yeah. Old. Scroll up. Scroll up. Scroll up. Okay. Yeah, I'm good. The feedback gamma is used as a signal to instruct the actor to rechain, which is used as the input of plan, open brackets, close brackets, period. In the actor critic reflection mechanism, the actor is responsible for the challenging plan making tasks, while the critic is responsible for the relative simple evaluation tasks. The two agents cooperate on two different types of tracks. tasks rather. Scroll up. Next page. And then we see an example here in in this rectangle over here. The intent by ChatGPT 4, and it's giving some suggestions, can suggest some type 1, type 2 basis. Then this is the plan by ChatGPT 4, SQL retrieval type 1 and type 2. Then we see another plan where it's after it suggests is retrieving. This is as well storing as well. And this is basically some examples of generated demonstrations in game domain. And then there's another example here of the memory bus and reflection.
Okay, so we have talked about the uh, the steps, the procedures, talking about the reflection. Yeah, so we've talked about the the plan first execution with dynamic demonstration. We have talked about plan. We've talked about execution and reflection. So, what can you say, or what are the contributions to these systems as related to the plan phase execution with dynamic demonstrations? Are you still on the? Can you hear me?
Can you hear me?
Yes, I can hear you.
Okay, cool. So I was saying that the framework is basically consisting of, or basically,
I don't know if it's from my mind, but you can't hear you. So we are just going to continue from
can you
there.
hear me now?
Yes, I can hear you now.
I was saying, uh, can you still hear me now? I was
I,
saying.
I can still hear you now.
So I was saying that the framework consists of 5 parts basically.
Okay.
Can you hear me? Can you hear me now?
Yeah, I can hear you, but your network
I
is
was
really
saying that
breaking.
I was saying that the the this system basically consists of 5 parts, which is the pipeline, the model, and a few other things basically. And what this system is talking about literally is how the data basically is being fed from the user and is processing it, and how fast can you process it, and it's making a comparison basically between the agent and the regular way of actually doing carrying out tasks like this. And it's the paper basically walked us through the planning phase, quite a number of stages actually. The planning phase, the execution as well.
Okay, so that's really cool. And you proceed with looking at uh, the experimentation setup. First, we have the evaluation strategy. So, and if you have any to wrap up from that particular session, do you have any question or contribution you would like to make lastly? Can you hear me? Did you hear what I said?
No, please reiterate your question.
I said in conclusion and to wrap up for that particular unit, what can you say? Do you have any question or your last contribution on the plan for the project?
I think I one no question. It's just the only for a project that I want to use this for would be a language, excuse me, system that I'm currently working on. It's nice that this helps in processing it way much faster. I like the fact that the we now have something that is way much better than what we've had previously, and I think that's just really a great improvement.
Okay, that's cool. So and we do still be on the call, so I can proceed to the other
Okay.
stepping up.
Yeah.
Okay, so we have I'm going to share this in the comment section. Okay, that's really cool. So we can proceed to the next session, and I'm going to be on to handle that session. So experiment. So in this section, we are going to experiment or what are the different routes or strategies that was being used to experiment this project. So let's look at the evaluation strategy under experimental setup. Evaluation conversational recommender system presents a challenge as seekers communicate their preferences and recommendation agent provide solutions through natural or both-ended dialogue. Design the following evaluation strategies. So here what was discussed was user simulator and also see one called recommendation. Okay, so user simulator manually fill a role name prompt so far. GPT for simulating reward users with buying preferences. A simulated user's preference is assessing by injecting their historical behaviors into the role to instruct. So the default configuration for the user simulation is set to session right. So this is all about looking at it from the user perspective because this approach is utilized to assess effi- efficacy of interactive agents with multi-tone dialogue setting and illustrative examples of user simulation prompts can be found in figure 4. Let's go to figure 4. So now this is the use case of it. You don't just want to have something like you want to make it more human and looking at it from the user or natural perspective. So let's look at it from the prompt. You are in this um use case. You are user chatting a recommender for item recommendation of your history, which is now your history based on, let's say for example, you're looking at history from something like Netflix or any history of your activities. Okay, your target item target here is the information about target. You could use target item info. So what are your target item info? This is then included there. So you must follow the rules below during chat. If the recommender recommends target, okay, you should accept. If the recommender recommends other items, you should refuse them and provide the information about target. If the recommender asks for your preference, you should provide the information about target. You should provide your history, your output is only allowed to be a word from the user you can. If you think the conversation comes to an end, I put end. You should never directly tell the target item. Only use the provided information about the target. Never give many details about the target items at one time. Less than three conditions is better. Now let's start. You first act as the user. Here are the previous conversations you have completed. So this is a very comprehensive from the user simulator, and we want to, from this perspective, model this system or test and experiment the system. So the simulator alternates between providing information either is data or target related. So let's look at it from this way. We have like targets being with the user, like so we have a recommendation system, and then the LLM is now being used to act as an alternative user, trying to work with this system. And we have a um, system of prompt here, whereby the LLM has to, say, okay, this is what is going on, this is what we have to do, and then the conversation keeps on. So from the user perspective, we say that the second strategy referred to as context initial, long context initial synthesizes multi-layer conversation, utilizing user history subsequent. Based on this extended dialogue, the user simulator interacts with the agents in a manner akin to decision wise. For our method, identity conversation history is related to the long-term memory. So remember the long-term memory module in the case that instead of let me just say putting in the entire prompt or the entire system, what happens now is you only retrieve relevant context, you only retrieve relevant information into into the history, into the prompt. Because if people adding the prompt and everything at once is going to go out of context. So this um, just of recently we have seen how these systems have now been built into they now have larger context windows up to 2 million, 3 million, and the rest of it. I think Gemini is one of the first that has larger context window. But in this scenario, we are retrieving we are not just passing the entire history as in a single prompt. So for our method, the lengthy conversation history is loaded into the long-term memory body. However, for baseline method, the extended conversation history will be resolved if it surpasses the maximum window size of LLM. Okay, good method. The experiment two was one ton recommendation. So I feel like this is a kind of recommendation whereby all the data is provided and the LLM just goes forward to do it to make the recommendation and then just giving it a one shot app. Okay. So following the settings for traditional conversation recommenders with that, we also adopt the one recommendation strategy, given a user's issue. Exactly what I said. We design a prompt that enables GPT-4 to generate dialogue, thereby emulating this interaction between a user and a recommendation agent. The objective is to ascertain whether the recommendation agent has accurately suggests the ground truth item in its text response. We assess both the item retrieval task, that is retrieval from the entire space, and the ranking task, that is ranking from providing candidates. Specifically, dialogue content is presented to the recommendation agent, accompanied by instruction. So, hey, give me K recommendation based on that chat history for the retrieval task and the instruction. Please rank this candidate item based on the chat history for the ranking task to ensure fair comparison with baseline LLMs. Okay, so I feel that this is way to another way to include to give these models one shot um, one sh- one shot recommendation because we are trying to simulate a real life chat history here. So one to recommendation. So okay, given this history, given this chat history, try to recommend a particular LLM or something even much more bigger or to be but I'm not just you know trying to recommend what's next, but being able to rank user items, being able to rank this targeted item based on predicting the next thing. So we have some references here to compare methods across different domains. We conducted experiment using this data set. This is let's see this data set. So the first data set self-attention sequential recommendation. I'm going to share the links in chat section. I'm going to share the link in the chat section so you'll be able to see the link here. So I mean everything here is inside the research paper, so you can always go back down. And so the models are baseline as dialogue recommendation agent. We compared our models based with the different baselines, random sample K items uniformly with the entire item set popularity, and also the models which was also used to create Llama 727 charts, Llama 2.13 charts, Vicuna 317, Vicuna 1.513 parameter. We have chat rate recently proposed conversational recommendation agent utilizes a text embedded to OpenAI. Okay? We also use ChatGPT 3.5, ChatGPT 4. So for the Llama and Buchanan models, we employ the fast chat package to establish local APIs, ensuring their interface is consistent with 3.5 and 4.0. So I think it was just like this pipeline of flow between this system and then finally the metrics. These both are methods and baseline initialized LLM to generate a response, which exhibits state of the art text generation capabilities are experiment with primarily compare the recommended performance method. So over here the you can see the performance of each of these models, okay, and the procedures to how this model will be evaluated. So comparison of different LLMs and the brain. Before then, let's look at the different performance of different models. You can see Llama 1.86 first, then 88, 54, 1.8 hours. So this was like what other machine learning models had out there, and the metrics in particular, this thing had. So comparing different LLM and brain, in previous experiments we utilized GPT-4 as an LLM for the interactive agent framework. This section presents a comprehensive analysis of the performance between different LLM interactive agents. Note that Reclama is a fine-tuned sound new model production section 3.5. So we can see here that during the evaluation of this model, the patient study under the evaluation PDR, the blank face dynamic demonstration and reflection mechanism, respectively. Note the dynamic demonstration also used or used as fuel. So, I mean, looking at the different models we can see here, um, for chart reg, we omit the result of the ranking task because chart reg degenerates into GPT when removing embedding based candidates. So, um, even if there is no one way or no right way to do a particular thing, in conclusion, you can see here that we introduce interactive agents, a compact framework that transforms traditional recommender models into interactive systems by harnessing the power of LLMs. We identify a diverse set of fundamental tools categorized into information query tools, retrieval tools, and ranking tools, which are dynamically interconnected to accomplish complex user inquiries within a task execution framework. To enhance interactive agent for recommender scenario, the comprehensive enhance the key components of LLM-based agents, covering the memory mechanism, the task planning, and the tool learning ability. Experimental findings demonstrate a superior performance of interactive agents compared to general purpose LLMs. By combining the strengths of the recommender agents, we by combining the strengths of the recommender agents, models, and LLMs, interactive agents pave the way for the development of advanced and user-friendly conversational recommender systems capable of providing personalized and interactive recommendations across various domains. So, I mean, this paper is really, really creative. For the past two sessions, we have been on this research paper, and personally, I have seen in different ways. I mean, I've learned a lot of new things, and it has opened up a whole lot of new opportunities to how these things can be done. So let's look at it this way. Recommendation agent has gone beyond just having to recommend based on a but your user your behavior. Looking at conversational history, it's actually very interesting whereby maybe in a situation an LLM can actually recommend what best fits for you or what would you like next in a particular use scenario, whereby you don't just have to, you know, we are not just doing um we are not just doing one recommendation and then that's all, but two two interactive two interactive chat and conversational agents. We can see in this case that these agents help us to you know, these agents help us to bring in recommendation into interactive. And the best line here that the best line of this research paper that was is interactive agent. And if you look at the behavior, combine this system together, I mean it's really a system that I think will be able to change the way reinvent or improve on how um, recommendations can be done. Because at the end of the day, we are looking at not just having this session, but how to integrate them into different scenarios, into different case studies. So briefly, before in the session, if you have any question, do well to drop it. And then case study. Let's look at the case study of this research paper to effectively visualize interactive agents' performance. We present a case study in chit-chat two domains, gaming and beauty products as shown in figure 6, and we compare outputs of GPT and interactive agents. So let's think we can go back to that diagram 6. Okay, this 36 and 37. Okay, nice, perfect. I think I just have to bring you here so you can see. So I mean, let's just go through this. Hello, who are you? Hi, I am an hello. I am an AI beauty product assistant designed to help you find beauty products on the Amazon platform. How may I assist you today? Who is the boss of Amazon? Assistant. As of my last update, the CEO of Amazon is Andrew Jassy. He took over the role of July 2005 to 2021, succeeding the company founder Jeff Bezos. User, how many beauty products do you have? As an AI, I have no access to a vast volume of information and can help you find a wide variety of products on Amazon. So, I mean, this has not just been able to build a recommendation system, although I'm yet to go through what the system has done. I mean, let's go through it. It also handles the problem of hallucination, because in this context, it's really grounded. So let's see targets, rimworld, higher update torchlight to endless legend, factorial, undertable in the past. Now I want some good player to be strategy games released after 2000. Sorry, I read the wrong thing. That is another use case, right? Let's continue because we are in the context of Amazon reviews for a beauty product. User hello, who are you? Assistant. Hello, I'm a conversational beauty product recommendation
assistant in Amazon platform. I'm here to help you find beauty products that you are interested in. I mean, looking at the tone, the preciseness in the way, even in the structure of the speech is really, really giving. Okay, can feel I'm here to give you recommendation. I'm here to give you product that you are interested in. Let's chat about your preference and I'll recommend some products for you. Who is the boss of Amazon? Assistant. The CEO of Amazon is Andrew Jassy. He succeeded the Bezos in July 2021. However, my main focus is on helping you find business products that you're interested in. These are how many. So, I mean, it does, although it can, it still goes a long way to answer this question. It still has this in context memory and it still has, it utilizes this to extremely well. Okay, how many beauty products do you know? I know about 8,600 and some 8 beauty products. Let me know your preference and I can help you find the perfect product for you. To me, this is just this project is delivered. I mean, like, this is also precise. It's so precise and it's solving this problem of not just hallucination, not just agents, but also, that problem of having to um, run out of knowledge base. So this is, I would really recommend this paper to anybody out there interested in building recommender agents. Yes, I can really recommend it. And if you look at this reference here, or this another use case here, this is not a 2D game, but it was recommended from ChatGPT 4. And with this system, we have framework, okay, which was the like target. Remember when we talked about the target here? So I'll say this is a very, very, very interesting research paper, and congratulate the writers and the people who wrote this research paper. We got 6 case study in chat, the stream game domain, and see Amazon Beauty e-commerce domain. So I mean that has been a wrap, and I really say this paper is delivered and it offers practical illustration to building recommendation system. And at this point, I have to say, anybody out there that wants to, jump into the world of research paper writing, or let me just say, build anything similar to LLMs integrations or interactive recommendation. I feel like this is the starting point because uh, here is the here is the you know can start from here, and that's quite the question. So I don't think there's any question, but if you have any question, do well to drop it in the comment section. So I can stop sharing my screen. And thank you all for watching this particular session. And Mr. Oh, do you have anything you would like to say or conclusion as regards to the session? Yes, you might want to unmute your mic and speak. Yes, unmute your mic.
Oh,
Okay.
sorry, I thought I did already. I was saying that no, I don't have anything I want to say. I think that I will just what all I just want to say is it's very much important since the data set is already provided available already. I will just take the data set and work with it and play around it literally and see what I can create basically with that. And I'm pretty much so sure that every other person on the call should actually do the same because it's really going to be some fun stuff.
So thank you everybody for joining. We will continue our session on Friday for our speaker will be joining us on India. Join our community, follow us on our YouTube channel to proceed. As for now, thank you everyone. Thank you for joining.
Thank you for having me as well.